Hey, welcome back to the Garden Runner channel. Thanks for everybody coming back. Today we're going to talk about aviation, uh, kind of at a crossroads in light aircraft power plants. What powers light aircraft? The engines, and basically the first thing that I can think of right off the bat is probably for the last 10 years, there's been talk about uh, getting rid of 100 low lead aviation gasoline because the EPA wants to eventually ban all gasoline that has lead in it. The only problem is that a lot of aircraft engines require pretty high octane fuel because when you're flying, you don't want to take any risk of any engine knock. So they deal with that with a quote unquote low amount of lead. Back in the old days, I presume the lead content was higher, and they came up with this 100 low lead, which reduced the amount of lead, but maintained a decent amount of octane. Now, I used to work with a guy that had a Cessna 172. He had a Site STC, a supplemental type certificate, which he did a modification where he was able to run automotive fuel in his Cessna 172. The only stipulation was that it could not have any ethanol in it. So he had found a special place somewhere out in the country somewhere where they sold automotive fuel without any ethanol. So he would buy like 5-gallon cans and fill up his pickup truck with unleaded automotive fuel with no ethanol, and he'd use it in his 172, and it worked great. I flew with him. I got in. He was a flight instructor, so I got in like 5 or 6 hours of flight training because I was a rusty pilot. And anyways, I got in like 6 hours flying and never heard the engine ever once miss a beat. So the STC does work good on certain aircraft. Probably with there may be a special thing that has to be done to the, like you have to lower the compression ratio or something. I don't know. But anyway, and another question, this is an open question to anybody out there. I don't know the answer to it. If anybody knows the answer, email me at 152runners.com or comment in the comment section. Or make a video yourself. But my question is to the public, people that know about light aircraft engines, do airplanes that have fuel boost pumps that supply fuel to the engine versus like gravity feed, like in your high wing Cessnas are gravity fed, but like airplanes that are low wings that have boost pumps, are those airplanes kind of quote unquote immune to vapor lock? I don't know. That's one thing I'm kind of concerned about using automotive fuel because it's lower quality and I'd be afraid of vapor lock. But with the use of a fuel boost pump, I'm wondering if that eliminates that problem. But I don't know the answer, so if anybody has an answer, let me know. I'd be curious to know. And then, of course, we got on the market, there's several kind of engines that are supposed to be replacements for your current modern day gasoline aviation engine. One of the engines that looks pretty promising is they have these diesel engines that you can use Jet A, and Jet A fuel is available anywhere in the world because jets fly everywhere in the world, or turbine airplanes fly everywhere. So that would be a way to solve the problem with the Hunter low lead, is just switch over to aviation diesel engines and just use Jet A. There was also an engine that came out years ago. It was called the Dynacam engine. And if I understand it correctly, this engine was able to use like the worst kind of fuel you could use and still run really good. Like you could use like 80 octane fuel, like really low octane. And it was called a Dynacam engine, and it was a very smooth engine. It had very low vibrations, and there was even it got put into an aircraft and it tested out really well. But then it never went anywhere. So, hey, if anybody knows about the Dynacam engine, comment below and send me an email at 152runners@gmail.com, or make your own video and explain it. So, we have, the big question is, what is the future of aviation 100 low lead? I do know that for like the really powerful piston engines, like in the Beech Barons and and the Cessna 310s, any engine that's like over 250 horsepower, I don't see how you're gonna be able to not, or I don't see how you're gonna be able to get away from 100 low lead. I don't see how you're gonna be able to convert those to auto fuel. Maybe it can be done. I don't know. But anyway, that's kind of a big question in the light aviation aircraft engines. And of course, one thing that's happening right now is like there's an outfit in Canada. It's either Canada or Alaska. They were operating piston aircraft. I think they're called the Beaver. They're like a Bush airplane. And they converted some of their fleet to electric. So they got rid of the gasoline and installed battery packs and installed electric motors. And they have electrified, I don't know what percentage of the fleet, but electric motors are much more reliable than, much less moving parts than a piston engine. And every time you go fly, you can always, quote unquote, fill your tanks full every time. It's not going to add weight to the aircraft. However, the when you're flying and you're using up energy, it doesn't get any lighter. Whereas an aircraft that uses fuel, a liquid fuel, as it's flying in the air, it's getting lighter and lighter and lighter. But on the positive side, your center of gravity in an electric airplane that's your center of gravity. You're not going to have to worry about, as you're flying along, the CG is going to change on you. Whereas in a liquid fuel aircraft, as you're flying along and burning fuel up, you have CG considerations to take into account. So there's a lot of advantages to going electric. Well, the big huge disadvantage, of course, is range. I think in the near term, maybe the next 10 years or so, the electrification of aircraft, I think, will work fantastic for short haul. But for long haul, we're still going to need liquid fuel. Either switch over to the diesel engines that use Jet A, or continued use of the gasoline engines. But one thing that can make that transition smoother, just like in the automotive industry, is the use of hybrid systems, where you have part electric, part gasoline, or part diesel / Jet A. And if I had the ability, like right now, like right this second, I had the ability to write a check and go, okay, I want to buy an airplane. I would, at this point, I mean, things can change. I could change my mind. But I would buy an airplane called an Aircam. It's basically considered an ultralight airplane, but it really has a huge payload. Anyway, it's a twin-engine aircraft designed by a guy named Phil Lockhart out of, I don't know what city in Florida it is, but it was originally designed to shoot photography and video over the jungles of Africa. And they wanted an airplane that had two engines because they were going over some really hostile territory. So anyway, this guy Phil Lockhart designed this aircraft, and they're in the third generation now. So it started off as a two-seater. Generation 3 is a three-seater, and it's got two engines. But if I had, like I said, if I could write a check right now and money was no issue, I would probably would buy two Aircams. One Aircam, I would just fly it. Of course, you got to build it. It comes 50% built, and the second 50% you have to build yourself. But what I would do is I would buy a used one and use it as get with some engineers and my idea would be to have one engine with the Rotax engine, and then the other engine would be electric. So you have the best of both worlds. But I don't even know if I'd even fly it. I would just test it. I may do high-speed taxis with it. And the other one would be an actual regular Aircam with the two Rotax engines on it. But anyway, I just thought I'd throw some ideas out there, things going on, that we need to look into the future and kind of have our inputs into the industry and try to determine which direction we're going to go power and light aircrafts in the future. So anyway, I hope this video gave you something to think about. And if you would be so kind, like, share, subscribe, comment, and ring the bell, and we'll see you in the next go-around. And you all have a nice day. Okay, so long. Bye-bye for now. Bye-bye.